All right, so let's get down to the smallest size now. So let's talk about atoms because we need to understand the chemistry of these to really understand molecules and bonds that make biology work. So this is going to pause again and basically answer what are these three components. So here we have an atom, right? We have the nucleus, and real quick, the nucleus of an atom should not be confused with the nucleus of the cell. Nucleus just basically is defined as center. And so this is the center of an atom, and the nucleus of a cell is much, much larger. It's an organelle. So this nucleus is tiny compared to the nucleus of your cell. But anyway, go ahead and answer what A, this kind of red part here with the positive charge is of an atom, B, these small negatively charged particles out here, and C, what are those? All right, as you probably know, the positively charged part of an atom is a proton. The negatively charged small parts of an atom that are flying around kind of the perimeter of the atom are the electrons. And then we have neutrons with neither a positive or negative charge, but do have a little bit of mass, kind of like the protons. So here we have a periodic table. And at this point, you want to be able to make sure you have access to a periodic table. You can just look this up online. You can get any periodic table, whatever works. But we're not going to spend a lot of time on this. Chemistry will go over these in great details. But we're going to focus in on some of the atoms, some of the elements that are really critical to biology. So most biological organisms are made of carbon, nitrogen, oxygen, some phosphorus and sulfur. And then if we add in hydrogen over here, that's really mainly what we're made up of. There's sodium, potassium, calcium, magnesium. Some of these ions here and these elements are really important for biology as well, but the vast majority of our mass is carbon, nitrogen, oxygen, some phosphorus and sulfur, and hydrogen. So what do all these numbers mean? So this 7 here basically is the atomic number of nitrogen. That means that nitrogen has 7 protons. It's the number of protons that really define that atom. So nitrogen has 7 protons. Then this is the atomic mass of nitrogen. And you can see that these are kind of have decimal numbers here. That's because not all versions have the exact same atomic mass. There are isotopes, and isotopes might have a little bit different mass. But if all of nitrogen has 7 protons, hence the atomic number 7, but may have different mass, the reason for that is because the number of neutrons can vary a little bit. So you can figure out how many neutrons nitrogen normally has just by simply taking the atomic mass and subtracting the atomic number. So if nitrogen has 7 protons, but it has a mass of 14, it must have 7 neutrons because the electrons don't really have much mass. So go ahead and answer your question about oxygen on the Ed puzzle, and then we'll move forward. So oxygen's atomic number is 8. It must have 8 protons, and it normally has 8 neutrons, and that gives it its atomic mass. Oftentimes, the number of protons and neutrons will be similar, but that's not always the case. Certain isotopes might have more or less neutrons than the common form. All right, so let's throw in the electrons now. The electrons are orbiting around the nucleus. And the electrons with their negative charge, they're actually moving quite rapidly, but that negative charge is attracted to the positive charge of the protons in the atom's nucleus, and that kind of keeps them orbiting similar to, in a physical manner to the way the planets orbit around the sun. They have momentum flying around, but they also have attraction to the center. In this case, that attraction is due to charge, and so that keeps them from basically just flying off. And so it's the electrons and understanding how that relates to the periodic table that's absolutely critical for understanding biology. So focus back in here and let's think about this. If you notice row 1 here, row 1 has 2 elements, hydrogen and helium. And they're kind of spread out all over here. It's this unique row. Well, that's because the innermost shell of electrons only holds 2. So this is row 1 basically just has 1 shell of electrons, and hydrogen would just have 1 electron because it has 1 proton. And then helium has 2 electrons because it also has the 2 protons. And then its shell is filled. And because that shell is filled, we now move to row 2. And row 2 adds a second shell a little bit further out. And you can see that in row 2 we don't just have 2, we have 1, 2, 3, 4, 5, 6, 7, 8. We actually have 8 electrons that will fill the outer shell. And these electrons like to be in pairs. So we would have 1, 2, 3, 4, 5, 6, 7, 8. We would have 8 if this whole outer shell was filled. But this is not neon. Neon would have its outer shell filled. We can see here that we have 1, 2, 3, 4, 5. We have 5 in that outer shell plus 2 in the inner shell. So 1, 2, 3, 4, 5. This must be nitrogen as long as it's in the non-charged form. So nitrogen needs 3 more electrons to fill its shell. Oxygen would need 2. So there's the nucleus, there's the first shell, and then there's the outer shell. All right, so let's think about these things for a little bit. So we just talked about how we have nitrogen. What would happen if the nitrogen atom was to lose an electron? All right, well, nitrogen normally has 7 electrons to counter the 7 protons in its nucleus. So if normal nitrogen is net charge 0, because the 7 positive charges of the protons are outweighed by the 7 negative charges of the electrons. So if you lose an electron, you have lost a negative charge. Now we only have 6 negative charges, but we have 7 protons still. So the answer to this, if nitrogen loses an electron, it's going to be a positive ion, positively charged ion. It now has 1 fewer electrons than it has protons, which means it has 1 fewer negative charge than it has positive charges. If it were to gain an electron, what would happen? All right, so if we were starting back from the neutral nitrogen that had 7 electrons to counteract the 7 protons, if it were to gain an electron, then it's actually now going to have 8 electrons, 8 negative charges, and only the 7 protons. And so that's going to become a N- ion. So ions are basically generated when an atom gains or loses an electron. And if it gains an electron, it's going to become a negatively charged ion. If it loses an electron, it's going to become a positively charged ion. All right, so what happens if the nitrogen ion were to gain a proton? All right, this is a trick question, because if nitrogen were to gain a proton, it would be neither of the above, because if nitrogen gained a proton, it now has 8 protons, meaning that it is no longer nitrogen. It would actually now be oxygen. So a little bit of a trick question there, but remember that our atoms are defined by the atomic number, which is defined by the number of protons. So if it gained a proton, it's now oxygen.